Before we start the login process using HTTP, we'll prepare for it by learning about async tasks. Async task was created because HTTP queries take up a lot of time and should not take place in the user interface thread. We'll begin by analyzing how Android behaves in case we want to call a long-term operation when using neither AsyncTask nor another thread. We prepare a long-term operation in our login activity in the place we've started new activities so far. In order to simulate it, we'll use thread sleep with a value of 20 seconds. After starting the application, we enter the login data and click the Login button. The moment we have a long-term operation, the interface freezes in a way. Until the long-term operation finishes, we cannot do anything with the user interface. If the operation is being carried out for a long time, Android informs us that the application has stopped responding. We get a dialog box where we can wait for the application to close. Users usually uninstall applications if this happens more than a couple of times. That's why it's good for long-term operations to be called not in the UI thread, but in async tasks or separate threads. Async tasks are preferred to threads because they simplify the communication between what is executed in the background and what is executed in the user interface. They simplify sending data between the two threads. Let's learn a bit more about the async task itself. This class is very often used in Android. It's usually used to perform simple, short, one-time tasks which have to be executed over a finite time. They make sense mainly if we want to inform the user interface about the progress or send data before, after, or during the execution of this operation. To make it possible, they have special calling methods in the user interface thread and a single special method called in a separate thread other than the UI thread. Thanks to this, we can easily separate the logic to be executed in the UI thread from the logic to be executed in the background. Additionally, during the execution of a long-term operation, AsyncTask may inform us about the progress. For instance, if we're copying a large number of files, after copying a single file, we may inform the user interface that some progress has been made. For that purpose, we use the progress update mechanism, which is automatically synchronized. Thanks to this, we don't have to deal with the synchronization of these two threads. We start with implementing a simple version of AsyncTask. For this purpose, we create the AsyncTask class. This class is parameterized using three main types. First, we provide the type to be used in order to pass the parameters to our async task, that is, the objects needed the moment the thread is called. Then, we define the type used to pass update, that is, the type of object which will be used to inform about the progress. Finally, we define the type of data which will be returned. In our example, we can assume that strings are our parameter because we want to pass a login and password. Given that we'll pass a number to inform about the progress will be an integer. As a result, we return a Boolean value, which will inform whether we've managed to log in or not. AsyncTask is an abstract class where we have to overload one method, the doInBackground method. It's used to execute operations in the background. The entire content of this method will be called in an additional thread which will be created for this purpose. We may notice that parameters are passed to the doInBackground method in the form of strings. This is because we specified a string as the first parameter in the async task. For the same reason, the value returned by the method will be a Boolean. With this method, we can easily call long-term operations. After such an operation, we can execute the test code. If we tried to call a code based on the activity inside the async task, we would get an exception. This is because the code that tries to start an activity must not be called in a different thread than the UI thread. We will treat establishing the login correctness as the result of a method. The code which has to be called in the UI thread can be moved to a specially prepared onPostExecute method. It will be called directly after finishing the doInBackground call. The result of this method will be returned as a Boolean. We just need to extract the values of the username and password fields. They are not available outside because they are present in an internal anonymous class. We could declare them as final, but a much better solution is to extract them via our mechanism. It's good to remember that we're dealing with a string array. This means that the subsequent parameters which we'll pass here will be packed as subsequent values in an array. In our array, under the value of 0, we should have the username, and under 1, the password. The only thing left to do is to start the async task. We already have a ready object on which we call the execute method. This method has identical parameters to the ones passed to the doInBackground method. That is why we pass the string array here, which in our case will include 2 elements. Let's launch our async task. The doInBackground method is called where the values we've passed are extracted. Then there is a 10-second delay, after which the value correctness is checked. It simulates an HTTP query to the server. We are now notified about the correctness, or lack thereof, in case of the login. If we manage to log in, we display a toast and start the second activity. As we're testing our app, we notice that the interface didn't freeze after pressing the login button. After 10 seconds, there appears a toast and a transition to a new activity. The thing is that we were able to start AsyncTask several times, so we can also start our activity several times. We can protect against this in a couple of ways. We can permit the async task to be started only once, or lock the login button for the time the async task operates. Let's use the second method. Apart from the onPostExecute method, there is also the onPreExecute method. It's called directly before starting doInBackground. It's also called in the UI thread, which allows us to operate on views. In our case, we can set enable to false on the login button. This will cause the button to become inactive. It will be impossible to click it. After finishing the doInBackground execution, regardless of the result, we'd like to unlock the button. Now, after login, we can immediately notice that the button changed its color. So it's set to the inactive state until the login is finished.